So we've recently been talking about different forces. We've talked about the gravitational force, which is a force that pulls down on an object. We have talked about the normal force, which often counteracts gravitational force, often pushing upwards on an object, or if there is a slant, it will be at an angle. Then we've also talked about the force of friction. Now the force of friction will will act in the opposite direction of your movement. And we have the static friction and we have the kinetic friction forces. They tend to work in the horizontal. And finally, we have the force of tension. And this force acts whenever there is a cable. So it could be when you have an object that's suspended or an object that is being dragged along the ground. Anytime there is a thin cable that does not stretch, we have the force of tension. So the next thing that we want to do is we want to take a look at a situation where we have multiple forces acting on one object, and we want to start to analyze that. And we're going to start by learning how to draw free body diagrams. Free body diagrams are abbreviated to FBD as well. Now, a free body diagram is very simple. We use a dot to represent the body. Or the object, I should say. And then arrows represent your forces. Now the arrows have to be pointing away from your dot when you draw this. So if we were to take a look at an example, let's say that we wanted to draw all of the forces acting on a, let's see here. Let's do a water bottle resting on a table. So this is just a sketch of a water bottle. Now we would represent this water bottle by drawing a dot. Now we would take a look and see what kind of forces are acting on it. Now it's resting on a table, and we know that gravitational force is always a thing. So the first thing you're going to want to do is draw in that gravitational force pulling down. Now we know that the table is preventing the water bottle from falling, so there's a normal force counteracting your gravitational force. There's no movement, there's no other forces acting on this bottle, so this is our free body diagram for the water bottle. Now, let's say that we have a lamp that is suspended by two cables. Let's draw the free body diagram for this one. So again, this dot represents our lamp. We have gravity pulling down. And we have these two wires holding it up. So we're actually going to have two different tension forces. So we can label them FT1 and FT2. And those are going to be at the angle that the cables make when they encounter the lamp. All right, let's try one more instance. Let's just erase this here. Perfect. So let's draw the free body diagram of a car. And please excuse my ugly car drawing. Driving on the road. So let's say the car is moving in this direction here. I'm going to start by drawing my dot that represents my car. We know that gravity is acting on the car. And because the car is not floating in midair, it is on the ground, there's a normal force pushing up. Now, we know that the car is being propelled to move forward. Now, it's not one of the main ones that we've talked about up here, but there is another force that we often use, which is called the applied force. So, force of applied. And that would be forcing it to move in the direction going to the left. Now, the last step is we need to figure out the force that counteracts this. And that would be your kinetic friction force. And it goes in the opposite direction of the movement. So your kinetic friction force is moving to the right. And that's all you need to know to draw Freebody diagrams. Thank you for listening, and I will see you next time when we start looking at Freebody diagrams and start looking at how we can resolve this to find our resultant force acting on an object.